All right, welcome to the November 13th study hall. We're going to be doing quant today, organizing word problems, which we did a little bit of. We did one problem that was a word problem at the end of the last study hall, but this is always a favorite of people. So we've gone through the rules as always. Copyright disclaimer: these problems are all from the Gmat prep software and our copyright GMAC. They're from the free software, so they can be reproduced. Extra English practice of everything. Well, if it's really everything, then the best thing you could do is just expose yourself to tons of stuff that are in decently well-written English. You know, there's kind of one or the other. I mean, the Gmat exam honestly tests very little of what could potentially go wrong in English. I mean, probably 1, 2, 3% of the things that a book might discuss. So really, it's kind of one way or the other. Either you're doing studying specific to this test, or you're just like reading a bunch of stuff in English. Kind of. That's what I'm saying. Like, the only place you will ever find Gmat-like questions is in Gmat resources. And even within those, honestly, most third-party materials do a very bad job of writing problems the way that Gmat does. So it's kind of one or the other. You kind of either use the real thing, or you just kind of read random stuff in English. Okay. Copyright there. These are Gmat problems. They own the problems. They're free, so we can reproduce them, but they own the problems. All right, let's go ahead and do one. How about this? And again, remember when you pick multiple choice options, this is where they are found. Multiple choice options. They are found here. All right, go for it. Okay, we're starting to get into the territory of lots of time, quote unquote. Here in the United States, we have this character called Smokey the Bear. He's been around for, I don't know, like 100 years or something. What he tells people, he's about to appear on the board. Smokey the Bear tells people that only you can prevent forest fires. But now Smokey has a part-time job reminding people about time management on the Gmat. And what he has to say about that is that only you can stop you from working at random quote work unquote. Remember that if you are not headed towards a definite goal, then you should not keep doing what you're doing. So there are actually 8 or 9 people who don't have answers to this problem yet. So if you are one of those people, you should guess at this point. Remember, this test, there's no option of not doing a problem or of like leaving it blank or whatever. Those are not options. Okay. Grace H. Hale number 2, James C. 1, Robert Sidesh. All right, let's take a look at this. So, okay, the theme of today is to talk about word problems. And the core of that issue is what makes word problems hard in the first place. Because what doesn't make them hard is the math. So, quick page where we'll have the more general, like philosophical discussion of this. What makes word problems hard? Because like one thing that if you just look at a few word problems that are on the Gmat, you'll notice that the math that you have to do is more basic, more predictable, more routine than the math on non-word problems. So it's not going to be bad. Because the math is easier, it's generally easier than on non-word problems. So what is the issue? Because a lot of people really don't love word problems. And the question is, why is that the case? Well, okay, so rephrasing, assuming you're talking about translating math words into math stuff. But why is that hard to do? So like for comparison, what you want to compare with is real life in which in real life people solve, quote, word problems, unquote, all the time that are much more complicated than the word problems that appear in Gmat. Like if someone has to keep a spreadsheet for tax purposes, for example, that could have hundreds of variables in it, but people don't think of it as that way, and so it's much easier. So what you want to do is you want to think about what do we do with, quote, word problems in real life. And after we identify what makes them hard. So what makes them hard is the step of translating statements that are in words into mathematical things. But there's a specific reason why that's hard, which is that not only are they in words, but they're in paragraphs. And that's really the reason at the end of the day why these things are hard. The hard part is dealing with mathematical information in paragraphs, which is really not a good way to present mathematical information. Like if you want a sense of just how bad that is or how unsuitable paragraphs are, like think about looking up your favorite sports team in a table of standings, you know, wins, losses, that whole thing. It'll take like 2 seconds to find your team, maybe 3 seconds. But then if they printed exactly the same information in a paragraph, just think how much longer that would take. I mean, you would figure it out, but it might take you 20, 30 seconds, which would be, 10, 15 times as long. So really, the choke point, the thing that makes this process hard is dealing with paragraphs. And a lot of people unwittingly make this process much more annoying than it already is by forcing themselves to go back to the paragraph over and over and over. Because every time you do that, you have to reorient yourself visually to the paragraph again. So the goal that we want here is to get the math out of the paragraph as soon as possible. Because that's really what the enemy is. And as far as doing that, if we think about what we do in real life, because in real life we don't ordinarily think of, when we have to do math as being some gigantic obstacle to our lives. So let's say that you wanted to make a spreadsheet for something, taxes, costs, budgeting, whatever. Well, all this starts from a rather brilliant observation. I'll tell you what that is. When we first make spreadsheets in real life, they're empty. I mean, you knew that, right? This is not really a giant revelation to anybody. But if you think about it, what people do with word problems in math is not like this at all. Most people start by trying to scribble equations in a way that is not organized at all and that has no framework. Like in real life, we make the framework first, and then we do all the math stuff later. And that's why these things are not that hard in real life, because we approach it in a way that makes more sense. So what we should try to do on these sorts of problems is we should try to do the same sort of thing. So just kind of follow the lead of what we do in real life. So on word problems, first thing we should do is it's like making an empty spreadsheet. So just physically organize the problem. And when I mean by physically organize the problem, again, it's like an empty sheet. This means to make some sort of empty organizational device. Notice organizational device is a very generic sounding word. It could be a chart, it could be a list, it could be a diagram, and it could be a table. I mean, who knows? It could be a lot of things. So let's do that. Let's physically organize the problem that we have here. Just think about making an empty chart for this. We're not going to do any math yet, and we're not going to put anything in the chart yet. If we're going to make some sort of chart for this, what's going to go on it? Like, what are some things that will go? So you have a total bill in dollars. You're going to have numbers of people. And you have all of these items for like two different situations, right? So notice where your eyes are going during this step. Like during this step, you are not paying attention to numbers or variables. But what you are paying attention to is stuff like units, what things and what units are in the problem. And you're ignoring numbers and math right now. That's how you make charts. The whole point of a chart is to not do math yet. So you have number of workers, your total, and so that also means that there's like dollars that each would have to contribute. And notice that there is agreed, like there's what they agreed to do, and then there is what they would have to do if a certain number of people reneged on that promise. So, and that's what NL presumably means by real and if. So if we can, rows and columns be a good way to do this, because we can make two rows for what everyone agreed initially. And then if some people back out or don't pay. Okay, and then those are two rows, and then we have three columns. Dollars per each person, number of people, and total dollars, right? So let's put those in there. Dollars per person, people, and that's total dollars. Okay, and then you can, you're going to be multiplying those eventually. But this is a framework, and that's the end of step one. Now this is the point where if you were doing this on Excel or some such thing, this is the point where you would start putting in your Excel formulas and where you would actually start plugging in things that are constant numbers. So in particular, there's going to be three types of stuff that you want to put in the chart or your device, however you do it. So numbers, if things are actually numbers, then you should put those in there. you should also put relationships in there. And what I'm going to suggest is that you should put those in there in words, not in variables. Yes. Well, we'll get into why in a moment. And then last but not least, make sure you indicate somewhere what the goal of the problem is. Like what is the thing in that chart that you're actually trying to find. Just, put a circle around it or mark it an asterisk or something like that. So let's put stuff in there. Okay. Stuff. So step 2. All right, well, let's see what we have. So numbers, and numbers are also things like variables too, sure. So let's just go through the paragraph and see what we get here. So what is T? Where does that go? T is which box? T goes in a box here. Which box does it go in? Yeah, it's the number of people that everyone agrees. So it's the top middle box. And then the lunch costs a total of X dollars. What box, where does that go? It's not just the top right. It's both of those, because the price of the lunch is not going to change depending on whether people back out of it or not. That doesn't change the price of the lunch. So this is still the same. And then what is S? So what we can do if you want to look at it with your eyes, I would just write underneath the number of people column, S people don't pay. Because then I can look at that, and it's easier to figure out what that does. Yeah, so you have to subtract out S number of people. So this is your T minus S. And then finally, what is the goal of the problem? Is the goal of the problem a box, or is it something else? The goal of the problem is what is the additional amount that the remaining people would have to pay. So yeah, it's just how much extra money. So what you could do on this device to indicate that is it's going to be the difference. I guess let me just put a box around that. You want to think carefully about which way you subtract these things, because which one of these is the bigger number? This is kind of just having the angle of common sense on your shoulder. But are people going to be paying more if everyone fills the bargain, or are people going to pay more if some people back out? Yeah, this is the bigger number. So it's not top minus bottom. It's bottom minus top. Yeah. So good. So the goal, and just write that on there. The goal is bottom minus top. Okay. And they gave you variables in this problem. That's kind of unusual for them to give you variables, which means that there are fewer things written on the diagram in words like this. But we still, when you write that in words, it'll help you figure this out. Now here's the point. The point is that, remember what's hard about this? We just did all the hard right now. We just got all the hard stuff out of the way, because we are done. We're totally done with the paragraph. Completely done with it forever. In fact, as a good test of whether you are organized enough, you should, obviously you don't want to draw on your screen or anything, but if they came and just stole the problem, at this point you would not care. You would not care at all, because everything is there. And you can use that as a test, because it's pretty much a black and white test. You either have to look back at the paragraph or you don't. So, and you shouldn't have to. If you are organized enough, you should never have to look back at the paragraph after this point. Should not happen. And again, this is a nice way to test whether you are organized enough. If you have to look back, that's where the time goes. Like people who are taking 4 or 5 minutes to solve this problem, it's not because the problem is hard. It's because you have to keep looking back at the words over and over and over again. So this is it. Okay. Now notice what we don't even have to do until we get here is pick a math strategy. That doesn't even happen until now. So here we actually have to pick an approach. You know, algebra versus back solving versus plugging numbers versus other stuff like that, and then try it. And then if it doesn't work, you're only back to step 3. You know, meaning that you can keep the framework. So, all right, here's our framework. Well, let's take a look at algebra first. If we're going to do algebra, then we don't need the answer choices, so we can do it on this page. There's not a ton of work left to do. Like what I want you to notice here, more than anything else, is how once you have done this, all you have to do is follow your own directions. Like if you wrote enough stuff on there, right? Like the relationship. What do you do with dollars per person and number of people? What do you always do with per anything? Well, you're going to divide, yeah, that's what you're going to have to do eventually, but right. So per person gets multiplied by number of people. That's not supposed to be solid green. That's better, okay. Because, you know, if you set it up at the very beginning, actually, you probably should have just written symbol number at the very beginning. But dollars per person times number of people is total. So if you have to undo that, then you're going to divide. So this is going to be division. It's going to get stuff in here. So if we're doing algebra, that is. So then this is going to be x divided by t. And this is going to be x divided by t minus s. And then you just have to follow the directions that you wrote. And I mean, the point here is that if you have written enough stuff on your device, you should not even really have to use your brain a whole lot after this point. You've written enough stuff down. You should be able to just go on autopilot at this point. Follow your own directions. Because, you know, we don't want to have to use our brains. We don't have to. So we can just subtract that. It's the bottom thing minus the top thing. So x over t minus s, subtract x over t. All right, well, that's a common denominator of t times t minus s. If you're going to multiply, this is going to have to be multiplied by t. So that's going to be ts. Because we're doing this. You have to make sure that you know it's being multiplied by all of this stuff too, not just one term. And then this is going to have to be multiplied by t minus s. Notice that if you know this is an issue, just flashcard it or whatever. But when you subtract this, the minus gets distributed to, and so does the x. This gets distributed to both of these terms. So this is minus xt and plus xs. So minus xt plus xs. These cancel out, and that leaves you with what looks a lot like choice D there. Only difference being that s and x are in the opposite order. So that's an algebra solution. how else can we do it once we have this chart here? What kind of substitution? Yeah, what we call smart values, smart numbers, just make up numbers. Right. So let's say that. So yeah, we can have 10 and 8. So let's let X be $100. Then T can be 100. Let's see, 100 divided by 8 is kind of nasty. But let's say it's really expensive lunch. Let's say it's like, or let's say it's relatively cheap lunch, $80. And let's say originally there were 10 people. But then 2 of them back out. So then we just do this math. This is $80. This is also $80. That's 10. Now it's 8. Okay, your S is 8. We have S is 2 here, so there are 8 people. Just whatever you pick, it's fine. And 180 over 10 is $8 per person, and now it's $10 per person. So then this is the answer that we want. We want 10 minus 8. And notice you've written all this stuff down. You don't have to remember. Like don't make yourself remember things. That's pretty much the goal here. So it's $2. Everybody has to pay $2 extra. So then if we try these values in the choices, X over T is $8. X over T minus S is $10. This is more than C, because that's C times a number, so that's even more than 10. We don't want that. SX is 2 times 80 divided by T is 10, and T minus S is 8. Okay, well, 80 is 10 times 8, and so that leaves us with 2. But remember, you can watch other sessions if you don't know why this is, but you do have to keep trying choices in case you get coincidences. But this is 80 times 8 over 10. That's a lot bigger than 2. So we're done. And it's D like a dog. Any questions about this? I mean, the things that you should notice here, there's a couple of things that you should notice here. The first thing is that if you, like, the thinking happens here. So that once you get down here, because you want to separate the tasks. You want to separate the organizing from the thinking from the math. And people, these are hard because people try to do all of that at the same time. You try to just dump it all on the table at once. So if you, like, when you get here, you should be able to you should be mostly able to follow your own directions. I mean, you might still have to think carefully about what kinds of numbers. Like if you're going to plug values, you might have to think about what kinds of values are appropriate. You know, like I had $100 here before, but then I made it 80 just because I don't want to divide 8 into $100. I'd rather divide it into 8. And you can adjust numbers on the fly like that, as long as you write them down. Just don't make yourself remember things. Don't do it. Any questions about this? Okay, I don't want to get any typing. Let's start another problem here. Let's do this one. A lot of people love this problem. This one's the big leagues as far as organization is concerned. This one is, there's a lot of words. Go for it. Okay, well, remember Smokey the Bear says, only you can stop you. If you're still working towards a definite goal, then you should keep going. But if not, then you should definitely not keep going. I'm going to give you a little bit more time to put a guess on there. While people are still populating the ABCDE thing here, let's just check in on something. What would you say would be, if you actually were not stuck and you got this problem, what would you say would be a good time target? Like, how long would you want to take to do it? Let's see what people say. That. Because the only answer in the chat box right now is the answer that you don't want to try. I mean, no way. 2 minutes for this thing? Not a chance. I mean, what is this? This is what I'm trying to call people out on here, because people have this weird way of thinking that you should try to do every single problem in exactly 2 minutes every single time. No. I mean, what is 2 minutes? What actually is that? That is the what? 2 minutes is the average time. Yeah. I mean, this problem is very clearly, it is not a maximum. It is absolutely not a maximum at all. If you think that it's a maximum, you're just not ever going to finish problems that are like this one. Because nobody, even people who have been teaching this test for 10 years or more, will still not finish this in 2 minutes. There's just no way. I mean, just don't forget this. I mean, time management is basically common sense, but a lot of people forget about common sense stuff when they walk into an academic environment or whatever. But remember that 2 minutes is an average. It's an average, guy. I mean, if you look at this problem, it's very obviously clear that this problem is way longer than average. So I mean, as long as you are actually doing things that have a goal. I mean, if you're stuck, then you should quit, even if it's only been 30 seconds. But if you think that 2 minutes is a maximum, you will never finish problems like this. It will just not happen. So, you know, if it takes 4 minutes to do this, it's fine. As long as you're not lost and just pushing stuff around. So, yeah, just common sense when it comes to time management. All right, let's. If you don't have an answer to this, go ahead and pick one. In multiple choice drop down here. Because remember, when you sit and take this test, you can't not pick something. It will just sit there and wait. So pick something, please. Grace H. Hale, number 2. KK Rafi. Alright, well, we're going to get started on it, but if you still don't have an answer yet, then, you know, just make sure you know the test is going to let you do that. Okay, step 1, let's organize this. This is really just making some sort of organizational device. So, let's physically organize it. And, you know, you might just have to invent a device if it doesn't neatly fit some template. Like the last one was dollars per person and people on dollars, which is your typical rate setup. But this one is a little bit more eccentric or idiosyncratic. But let's just go through it and see what's up. So this year we have an amount that is saved and an amount that is spent. And then next year, next year it's a totally different scenario. So we're not going to be able to make rows and columns here because there's no saving and spending. There's spending, but there's an available amount. For each dollar he saved, we already have that. That's the same as that quantity right there. So, and then you have this interesting, what is this 1 plus R thing? For each something, there's 1 point R of something else. That's yeah, it's a ratio. It's gonna be a multiplier, right? So we'll put that in there in the next step. And then finally, you have a fraction saved this year. So that would be this thing divided by the total income. So all right. And then let's just make sure there's nothing new here. The amount he has available to spend, that's already there. And the number he spends this year is already there. I mean, remember, you can't actually highlight things on the problems because they're on a screen. So on your paper, I would just first take an inventory of everything that we have to organize here. So for this year, we have a total income. We have that breaks up into saved and spent. And then we have the fraction for saved. So saved dollars, we also have spent dollars, and we have a saved fraction. And then for next year, we just have, looks like all there is available to spend next year. Okay. I mean, that's not as scary as it looks in the paragraph. Remember, a lot of the words are repeated. So this doesn't look like anything that is very patterned, so to speak. So I'm just going to put this stuff in a straight line and just draw on it. Because remember, if you don't come up with a smart way, I mean, if you don't come up with a cute way to organize this stuff right away, then just put it all in a bunch of columns. So, all right, this year we have income. And then that's going to be a fraction saved. So then dollars saved, and then dollars spent. And then next year available. And that's it. All right, and then other columns. Nothing fancy. Just divide them out. Okay, that's step 1. Step 2 is to get all the stuff, junk, out of the paragraph. So let's just get that out of there. All right. Well, and I mean the columns actually, this is not a data sufficiency, so we don't need the columns to be that tall. So we can shorten that. In data sufficiency, you would want nice tall columns because remember you're testing cases and stuff. But here we're not going to need it because these are just boxes with single entries in them. So, all right. Well, what's the relationship with income and fraction saved and dollars saved? Yeah, what is the equation for the Some people are typing. No algebra yet. Because we might just not want to do that. I think maybe you guys, yeah, that's all I'm looking for right now, is just that. You total amount times the fraction saved is equal to the amount saved. So we can put that on there. Those are, they might be hard to see, but let me just move those. Okay, so that times that is that. And then notice that dollars saved and dollars spent. I'm just going to draw these little curvy lines here. Because remember, as long as you understand for a few minutes what this is, then you're fine. So these two together add up. That is the point. And then what is this 1 plus R business? For each dollar he saves this year, there will be 1 plus R. So that's a multiplying thing. So let's just write that. We have multiplied by 1 plus R. And that gives us this. And that's actually it. So there's one more thing. Okay, there's a goal. The goal is what fraction? So this is the thing that I want. And this is the last thing. The amount he has available to spend, that's this thing, will be half of this. That means that this is twice as much as that, which is, I'd rather think about twice as much than half as much. So I'll just draw another arrow on there. If I do that, that's times 2 going in that direction. Or I could cut it in half going in the other direction. I mean, okay, there's a lot of wires in this diagram, so to speak, but, you know, at least it's got everything in it. So that god-awful paragraph up there, never again. Don't need it, ever again. Gone. That's kind of nice to know that we don't need that anymore because it's ugly. All right, let's say that we're going to do algebra. Why not? In that case, what do we want to do here? I mean, we probably want a variable for this because this is the want. This fraction saved. So at least that. And then income, well, let's do that too. So then we just follow the arrows. I mean, notice there's arrows that we can just follow. Boom, boom, this equation, that. We don't need the brain power thing anymore here. This is income times fraction is this. That's I times S. That just kind of happens. And then these together are that. So what do we do to fill this column in? Total income is I, and you save that much of it. So you just subtract them. Sure. All right, then we follow that bluish, aquamarine, whatever colored arrow. So that's going to be IS times 1 plus R. And then last but not least, we follow the red arrow times 2. And that's what I've got. That's puts another thing in the same column. But wait a minute, now I got two things in the same column. That means, what can I do with these? If they are both in that column, then yeah, you set them equal, because that means they both represent the amount of money that was spent this year. So I minus IF equals 2IF times 1 plus I. Now you can get an I out of there right now. We've been carrying it around with us, but it's just multiplied by everything. So if you don't see that you can pull it out, then you can explicitly factor it on the left-hand side. And you can factor it out of the right-hand side too. So then we can, I mean, the income is clearly not 0, because otherwise you couldn't talk about fractions of it. So we can divide by it. So if we divide both sides by it, it will just go away. That's kind of neat. And then what is the thing that we're solving for? The thing that we're solving for 1. So F, and conveniently, just glance at this to make sure, because getting I to go away was good because there's no I here. But now all that's there is numbers and F's and R's, which is totally okay with us. So 1 minus F equals, just multiply it out, 2F plus 2R. We want to solve for F, so we want to put the F to the other side. And then we pull out, let's get that by itself. So R goes to the other side. And I think I did something not right. Yeah, this is 2F plus 2FR. Just seeing whether you guys are paying attention. So then you can factor this out, because F is in both terms. And there you go. So 1 over 3 over, it's 1 over that. So just double check. I mean, it's kind of easy to pick C if you're not being careful here. Because, oh, look, there's a 3 and there's a 2. But no, it's the 2 times the R, and it's the 3 is a number. So that's that. I mean, it's kind of neat, right? After you have these arrows in there, you kind of don't have to think at all. You just follow them. You just do what you wrote, which is kind of cool. Not to mention way more efficient. Because, I mean, if you don't pull all this stuff out of that paragraph all at once, I mean, you're never really going to feel sure that you've gotten all of it. Because there's so many words there. Like, how do you know there's not more waiting in there for you? But if you just go through line by line and pull it all out and put it in there at once, then you know you've got all of it. So not only is it much more efficient, but it is also, it's also a lot more secure. I mean, you know that you got everything is basically the point. Let's talk about another approach to this. Let's say that you, here, again, we don't need paragraph anymore. So let's just go on it. But here's our organizational device. That's so big. I mean, how else could we do that? Anybody got any ideas? Let's talk how we do smart numbers. So we can, I mean, R is variable here. So if you can pick that. what you'd want to do is make sure that when you pick an R, we don't want to go through all of the song and dance and then find out that there are 2 answers that survive. So you want to consider for a second, like letting R be 1 would be a bad idea, because if R is 1, then these are both 1/4, and these are both 1/5. But if R is 2, then we just make sure that we get different fractions. If R is 2, that's a 4th, that's a 6. This is a, 6 plus 2 is 1/8, this is 1/5. And this is 1/7. Okay, those are all different, so we can let R be 2. And notice that we're front loading the task of plugging in the choices, just because if any of these are the same, then you abandon that and you pick another R. All right, so this is 3 now. This is just times 3. That's times 3 is a lot nicer than times 1 plus R. And that's the blue arrow. Everything else is kind of the same. Okay. Well, now what? We could do what we did before, right? Because the thing is, well, that's great, but nobody has to do it under 2 minutes, so we don't care. Trying to do this in 2 minutes. Anyone who thought they had to do this in 2 minutes would, by definition, not be a genius, because they wouldn't understand time management. Yeah. You can do the same thing we did before. Now we're not going to have to deal with as much algebra. You can still do like your I and your F here. So this is IF, this is still F minus IF. But then at least you don't have that 1 plus op. Because this is times 3 now. And then that's times another 2. I mean, that's going to streamline things a lot. Because there's a lot less rearranging that has to happen here. This is F minus IF is 6IF. You can move IF over and right away, right? That's pretty cool. That's an I. This is an I, not an F. So that means that that is also an I, and that is also an I. Minus I is just equal to 7IF. I is gone, 1/7 is that. That's pretty freaking cool. You can also do that. Even back solving is even possible, although back solving is a little annoying. But you can try that at home too. So smart numbers are a good way to approach this too. But yeah, don't tell yourself you have to do this in 2 minutes, because if you do, you just won't do it. Yeah, 3 minutes, 4 minutes, totally not a problem here, as long as you are still headed towards a goal, then you are fine. That's the point. Any questions about this problem? And again, the thing that should make the biggest impression here really is that the total lack of struggle once you have all these labels on there. Like once you get to step 3 in our little system where you pick a strategy, but you have all this stuff. You do a bunch of arrows and you just follow them, which is kind of nice. Yeah, but if you're going back to the paragraph and picking stuff out of it 5 times, think about efficiency. Just get it all out at once. Very cool. All right. Let's try another one. Go for it. Again, trying to do this in 2 minutes would be a very bad idea. Don't do it. Go for it. All right, Smokey the Bear says, only you can stop you. You don't need to assume anything that it doesn't say in the problem. Because, you know, that's going to shake out from how these numbers work out anyway. So, if you think about it, you're not going to have the freedom to pick X. Because if you make up a random X, then you're not, unless you are extraordinarily lucky, you're not going to get these numbers. So, but let's pick a thing. Pick an answer choice, please. And then yeah. Okay. Let's see, we've got Hale, Jessica, KK, Who, Rohit, Robert, Russ, Vivek. Go ahead and pick an answer, please. Here's the problem in somewhat smaller font. So let's talk about, if you want to elaborate on what process of elimination you're talking about, that would be cool. Just a brief explanation of what you mean by that. All right. Well, let's talk about let's talk about what's going on here. Physically organize it. So what are these numbers? Okay. I don't know what you guys do by 20 minutes, but we'll get there. So you have these two kinds of situations, right? You have if there is production below a certain level, and then you have if there is production above a certain level. And then if there's production above a certain level, then you've got two different rates. So let's think about how we would do that. Well, because everything we do, we want to do it twice. It's with data sufficiency in general, right? So, because remember that data sufficiency problem is not really a problem. It's really two problems. So you should make two charts, just two copies of whatever your thing is. And then if you have to, you can import. If you have to combine the statements, you can always import information from one into the other. So, well, it's kind of like you have, if it's sort of like your actual hypothetical, or in that first problem we did today, you had if everybody pays versus if everybody doesn't pay. Rows. I mean, we can make rows for if it's 36 or fewer. So if production is one row for if production is 36 or less. And then another row for if it's greater than 36 items. Okay, well, if it's less than or equal to 36, then you just have a per item. This is just a normal rate per item. So, and then it's numbers of items. And that gives you your total money. And then this is like up to 36. So let's just, I mean, that can apply to both, because in either case, you've got up to 36. That's all you've got in that first row. But then we can just do it again for beyond 36, because we got a different rate. So that's not going to apply to the first row at all, but we can just do the same rate setup for the second part of it. Because we don't want to try to collapse that into one thing, because it's differential rates. And we can actually just make the columns, because the top right is going to be all zeros. Because we don't, in that case, there's no production beyond 36 items. Okay, and then that's physically organized. That's step one. And then we need to make another copy of it. So we just do that. Let's make another copy of it. So do that at the start. Don't make yourself do it later. It takes about 8 seconds of your life or something. And this will be for statement 2. Okay. Now let's put stuff in there. Where does X go? Yeah, it's pretty nasty looking, but notice that you're mostly done with the brain work. I mean, it's really, the work is up front. You have to not be afraid to do this. I mean, you get lost, then you quit. But if it's, wow, this got kind of, this metastasized a little bit, but you at least know what you're doing, then it's fine. Where does the X go? You guys are going to notice there's not a lot of brain work after you get this filled in. I mean, we've done like 90% of the brain work already. It's dollars per item up to 36. So that goes in all 4 of these columns. And then actually there's more, like if it's more than 36 items, then we can fill these in right now, because you make all 36 there. So we can fill those in here too. All right, well, this isn't so terrible. And then 1.5 times that amount would be 1.5 X. So now how do you do, let's say that you have N number of items. Then what is this? This would just be the N items. And then this would be N minus 36. And then that should be N times X. That's here. Not just N, not just that. Okay. And that's going to be 1.5 times NX minus 1.5 of 36, 54. That seems kind of ugly. And, I don't really love where that's going. So, this is not my favorite thing. So what I'm going to do here is I'm going to stop what I'm doing, because I don't really, this looks like it is not going to go very far. So I'm gonna not do that, and that's fine. If you hit a wall, then you don't do it. Let's think about the individual statements for a sec. Because remember, you want to not lose sight of your goals, right? How many items did Bob produce? Can anybody dispatch the individual statements quickly? Because if you remember, your goal is either that or that, depending on which pricing scheme you're looking at. Because you could have, remember, you could have absolutely any pricing scheme here right now. These are all variables. So here's a way that you can knock out the individual statements relatively quickly. You can just say, if this is 480, then you could have made one item for $480 each. Or you could have made two items for $240 each. It actually proves that it's not sufficient. Because that's two possibilities. I don't even need to mess around with that bottom row. Because there's already two possibilities for a number of items. 510 is the same kind of thing, right? I mean, 510. Well, that could be one item at 510 each. Or it could be 10 items at $50 each. All right, not sufficient. Remember, don't lose sight of your goal. I mean, if you can get there to be two item prices, then you have just established not sufficient. And you might not need a lot of song and dance to do it. Now, this is where it gets interesting, because you got to combine this stuff. If you want to combine these, so let me condense here a little bit. Move this up a little bit. And we can make that smaller. All right, the highlights are off, but that's okay. What do we know? If we get the two statements together, here's the chart again. Look at that being 480 and that being 510. Yeah, what about those extra two items? Right, you can think about those, because that means your extra two items cost $30. So the extra two items are 15 each. So how might we try to create, because remember the goal is to see if we can get one possibility versus two. I mean, why doesn't this immediately mean that it's sufficient? Because I mean, in a lot of problems with money and rates and stuff, you could do this and you'd be done. Yeah, because we don't know if the 15 is this original cost per item, or if it is that cost per item. So if that's 15, because remember that's 1.5 times, it's like overtime. So this would have been 10. Or that could be 15. If it works out both ways, it's going to be not sufficient. And then in this case, we could fill out. If it's that, then this is going to be last week. I mean, actually, we should divide this up a little bit more. Last week is 480. This week is 510. Those are the weeks. So does 15 go into those? 480, 15. That looks like, I'd have to do it on paper, but my computer said it's 32 last week. That's workable. Last week would be 32. 15 into 510 is 34. So that you can make that happen. And then the only other thing you're trying to do is to see if it can work over here. So that means both of these would have to exceed 36. This is going to be 360 regardless. That means you're supposed to have 480 and 510. So to make that happen, you would need 480 minus 360. It's 120 this week. And then that's last week. And then this week you would need 510 minus 360. Does that work? Well, let's see. Yeah, it does, right? 15 times 8. 15 times 10. So overall, then you are making, what, 36 plus 8? You're making 44 items last week, or 46 items this week. So there are two possibilities. We made it happen both ways. There's that set of possibilities. And then there is this combined set of possibilities. So it's still not sufficient, even if we have the two statements together. So what you want to notice there, you know, I saw a bunch of algebra and I was like, nope. I mean, you can do that if you set up a bunch of really ugly things. Then you can just abandon that. You're not committed to any solution path that you're trying to follow. So then just back up, think about it. Well, not sufficient is pretty, if you can back off of that, not sufficient was pretty straightforward to get individually, because you could just divide these 480 and 510 up any way you want. But then the organization, I don't know if this, I mean, doing this without having the organization would be very, very hard. I don't know if I can do it. So, but when you set this up, it's not that bad. You just have to know what it is that you're trying to accomplish. And of course, you have to not think you have to do it in 2 minutes flat, because you don't, as long as you're headed somewhere. Any questions about this? And I mean, notice this problem is very fun, but at least you could get rid of A, B, and D pretty quickly, because if you just, you know, you can break these individually up into lots of things. So then you got a 50-50 guess. That's pretty good. I mean, 2 choices to guess from, it's not bad. And I mean, if you think about it, if they're going to go to the trouble of creating this kind of scheme, it's probably going to work out both ways. I mean, if I had to guess, I would have guessed that it would work out in each way. But at least it's an even 50-50 shot if you have to guess. Not terrible. Any questions? If not, then that's it. Probably do let's save another chunk of these. We're actually having another session next week too. So that's 1 week from today, and it is at the same time? I don't remember. But yeah, the timing of these things is going to be a little bit random because we're planning them around a lot of holiday-related stuff. But the next session is in 1 week from now. So that's definitely a thing. All right, yeah, this one's a cool problem. Yeah, they put a lot of thought into it. All right, let's wrap it. So thanks for attending. Remember to check the webpage for the time of the next lesson. I don't decide the topics until like an hour before. So there's not really any kind of continuity because that's the point. I mean, it's a free product, so if we made it organized, then that would be bad business. All right. Thanks, guys. Good night and good luck. Okay, kill the recording.